All right, so I think this is recording. Let's take a look at these two absolute value inequalities. In each case, we want to start out by getting the absolute value by itself. Uh, let's take a look at number 13. I'm going to add 1 to each side. So I've got 6 times this absolute value is less than or equal to 108. If I divide both sides by a positive 6, since it's positive, I don't have to change the direction of the arrow, and I think 108 is divisible by 6. Let's check my calculator and see. Yeah, 18 is what I'm getting. So I can write this as a compound inequality and write it as negative 18 is less than or equal to 6 minus 8x, strictly less than positive 18. I know that with the arrow pointing towards the absolute value, then I'm going to be shaded the middle part of the number line, not the tails. So let's get this x by itself. Let's subtract 6 everywhere. We've got negative 24. 18 minus 6 is at 12. Now, if I divide everybody by a negative 8, the arrows are going to change direction. Negative 24 divided by negative 8 is a positive 3. And 12 divided by 8, that fraction reduces, since both of them are divisible by 4, to 3 halves. Now, I like to write it with the smaller numbers on the left with my arrows pointing the other direction, because when I go to shade my solution set, the arrow and the direction that I shade, everything matches up better on the number line for me if I rewrite this compound inequality like this. So by having the smaller number on the left, like I say now, when I come in to sketch my solution set, I've got 3 halves, which is about 1.5, well, which is 1.5, and 3 is bigger than 1.5. Now, to determine whether to include these endpoints, we look to the inequality, and we see that it's underlined that it contains the equal sign, that it contains equality. So we're going to include these endpoints in our solution set. Remember that we want to be bigger than 3 halves, but yet smaller than 3 at the same time. That's this middle portion here. And written in interval notation, we have brackets. 3 halves is smaller than 3. So here's my solution set for number 13. Let's take a look at number 14 and see what we have here. Again, we want to isolate the absolute value. So we have 8 over 3, negative 8x over 5 minus 3 halves. We're going to subtract 27 over 8 from each side. I think we've seen in these problems that 8 divides 120. Yes, 15. So I have subtraction here of these two fractions, but I'm not going to be able to do this subtraction until I get a common denominator. So I'm going to use 120 as a common denominator. It's 27 over 8. I'm going to multiply it by the number 1. But I'm going to be clever in how I write the number 1 so that I get a common denominator. Here I have 8 over 3 times this absolute value as being strictly greater than, like I say, I've got my denominator of 120, but I don't know what 141 minus 27 times 15 is. So I'm punching that in a calculator, and I get 736. Now I can see that this fraction is going to reduce, and I'm going to reduce it because I like working with the smaller numbers. Let the calculator do the heavy lifting for me, and hey, let's see what we have here. Copy down this other part. Greater than 92 over 15. So to get the absolute value by itself, this coefficient, I'm going to multiply by the reciprocal. The reciprocal of 8 over 3 is 3 over 8. So now when you multiply reciprocals here together that are non-zero, the product is 1. If I multiply the left-hand side by 3/8, I've got to multiply the right-hand side by that. Let's look and see what we get. We've got this absolute value, and greater than what is 92 divided by 8? Is 8 divided? So if I have 92 times 3, 276, and divide that by 15 times 8, and reduce that fraction, I get 23 over 10 if I've keyed that in right on my calculator. Now, with the arrow pointing away from the absolute value, I know that the away from the middle is going to be shaded in my solution set. It's what I refer to as the tails of the number line. That's not a mathematical description. That's my own description. I'm sure I've heard a teacher or professor probably say that before, and I just don't know who to credit it to, but that's how I think of it, as being in the tails, being away from the middle. See, here in number 13, we shaded the middle part. That by the tails, I mean the arrows, away from the center. All right, so we're going to split this into two inequalities. We've got negative 8x over 5 minus 3 halves. I change the direction of the arrow. I change the sign of the number. And I know that that expression is strictly less than negative 23 over 10, or I have this expression that is strictly greater than positive 23 over 10. So let's get x by itself. If we add 3 halves to each side, I need to multiply the 3 halves by the number 1, but I need to write 1 as 5 over 5 so that I get a common denominator of in each fraction of 10. So on the left-hand side, I have negative 8x over 5 as being less than, with this denominator of 10, negative 23 plus 15 is a negative 8. I definitely write too big, don't I? All right. So this negative 8 over 10 reduces to what? Negative 4 over 5. I'm going to go ahead and write that now. Negative 4 over 5. Now this problem is beginning to look familiar. I wonder if I've accidentally copied the same problem and did it earlier in the worksheet. Multiply both sides of this by positive 5. I've got negative 8x is less than negative 4. If I divide both sides by a negative 8, I have to change direction of the inequality, and that's 1/2. Now let's come over and solve this other inequality. Yeah, these numbers, all of a sudden now this is looking very familiar to me. If I add 3 halves, again, I'm going to multiply by the number 1, but I'm going to write the number 1 as 5 over 5, so I get a common denominator of 10. So I have negative 8x over 5 greater than or equal to 15. 23 plus 15 is 38. 38 divided by 10, is that the same as 19 over 5? Multiply both sides by 5. Yeah, this is looking, I'll bet you I have done this. Divide both sides by a negative 8. change the direction of the inequality. So let's make a picture of our solution set. So we have this negative fraction. On the number line, negative numbers are to the left of positive numbers. And we're not going to shade in our critical points here because it was a strict inequality. I want to the left of, I want values of x that are less than this negative 19 over 8. So I'm going to shade to the left. I want values of x that are strictly bigger than 1/2. So I'm going to shade here to the right. So now to write this solution set in interval notation, we've got negative infinity, comma, negative 19 over 8, union 1/2, positive infinity. I've got my answer key somewhere. Let's check and see. Yeah, oh, I've got a sign error here. Let's take a look at it, either in my answer key or in my work. Maybe you saw it and we're screaming and yelling. So let's come back here. Double check. When I add 1 to each side, I've got 108. When I divide by positive 6, 108 divided by positive 6 is 18. This becomes negative 18 less than or equal to this expression less than or equal to positive 18. If we subtract 6 everywhere, negative 24 and 12, that looks good. If I divide by a negative 8, and there it is. When I have positive 12 divided by negative 8, that should be a negative value right here. So this should be a negative number, and this should be negative, this should be negative, and negative 3/2 is definitely less than positive 3. So there's an example of, hey, you've got to be careful. But if you showed your work there, you're going to, I would give a student most of the credit there. Now, if for some reason this positive 3/2 would have been bigger than 3, that should have been like a warning signal. But here the fraction 3/2 was less than 3. So be careful. Sign errors are the enemy. It's very easy to do. Hope that helps, and I'll talk to you later. Bye.